Shalom to you and welcome. In this video, we'll look at surface area of circular solids, three-dimensional figures that has circles as part of them, like cylinder, cone, like you see an ice cream cone, or sphere, like in balls or earth. So we're going to calculate their surface areas. Again, I've named them cylinder, cone, and spheres. A cylinder has two congruent parallel bases, just like a rectangular prism. Two bases, but only the two bases are circle. They have to be circle and no other shape, not polygon. A cone resembles a cylinder in the sense that it has a circular base, but it resembles a pyramid because it has a vertex. A sphere is a special figure. It has no lateral edges. It's just all round. So we can only calculate the total surface area of it. So we demonstrated how the lateral face of a cylinder can turn into a rectangle, like if you open up a roll of toilet paper or paper towel. The lateral area, roll it out, is going to form a rectangle, and the circumference of the base is going to be the length, and then the height will still be the height, and then the two bases, top and bottom, are going to be circles. So to find their area, we just find the area of the circle, and then calculate the 2 pi r times height. That will be the lateral area of a cylinder. When the cylinder has two bases, for example, sometimes you're asked to find the surface area of an open container that is cylindrical, then we don't have to multiply by 2. So watch it when you need to multiply by 2 and when you don't. Okay. A cone, we can also see that if we fold a paper, a sector of a circle, we get the lateral face of a cone. So that's where the formula comes from, and we can demonstrate this in the class. Okay? But the lateral face is pi radius slant height. L is for slant height. Sometimes you see it written as S for slant height, but that's the slant height, and this slant height is the radius of the sector. Okay, a sphere, like we already said, has no lateral area. It has no lateral edges. So the total area is 4 times the radius of a circle, which is pi radius square. And the way to prove this formula is beyond geometry, is in calculus. So, but we are just going to calculate with this formula the surface area. So let's do problems, solve problems. Find the total area of a cylinder. So it says it's a cylinder, so let's draw it. Again, has that. And we are given the height. So the height is 8. This is the height here, so it's 8 inches. And the diagonal, so it's going to have a diagonal inside. The diagonal is 10, and that's all we are given. Okay, so we need to find the surface total area of a cylinder. What do we need? Write the formula, the area of the two bases, so 2 times pi radius square plus the lateral area, which is 2 pi radius times height. Okay, watch it. The lateral area, we do not square the radius because it is 1d, again, is circumference. But in the area, we do square. So find each of them separately before you add them, if they all have pi in them. So, but what do we need? We have the height. Height is 8. We need the radius. We don't have the radius, so we're going to find that. but we see the diameter D makes a right triangle with the diagonal and the height. So they're gonna have a right angle there. So we can use Pythagorean theorem. Okay, watch to find the diagonal. I mean to find the diameter. So so that's this length here. We call it D. Alright, so we're going to do the hypotenuse is 10. So 10 squared is equal to 8 squared plus D squared. And so 10 squared is 100. And we can go ahead and subtract 8 squared from it. 8 squared is 64 equals D squared. So that would give us 36 equals D squared. And we take the square root of 36, it's going to be 6. So D is 6. So which means the radius is going to be 1/2 of the diameter, which is 3. And that's what we need. We need the radius. Always remember that we need the radius, not the diameter. And now we can plug things into the formula. We have everything we need now. So the total area is going to be 2 times pi times the radius is 3, which is 3 squared, plus 2 times pi times the radius, which is 3 not squared, times the height, which is 8. Okay, and then we simplify things. This is 9 squared. 3 times 3 is 9. 9 times 2 is 18. So we have 18 pi plus, here, 2 times 3 times that, times 8 is 48. 48 pi. So since both of them have pi in them, we can add them together, and that will give us 66. Okay, 66 pi, and this is in inches, so it's area in square inches. And that's it. Again, you see how that involves Pythagorean theorem, so sometimes that happens. Alright, next one. This is a cone. Okay, let's draw one. Cone is kind of easy to draw. Let's just make a V, like ice cream cone, and then the invisible part. And we are given the height. So this is the height, which should go from the vertex down to the center. That's the height, which is 8 feet. Okay. And we are given the diameter. So the diameter runs from both ends, and is 30 feet. If the diameter is 30 feet, then the radius is going to be 15. So we can make that 15 feet. And that's the slant height. So we don't have it. And in the formula, let's write it out. It's always good to write the formula out. That way we know what we need. So the total area is going to be, the base area is pi radius squared because there's only one circle. And then the plus, the lateral area is going to be pi radius slant height. Okay, so, and we don't have the slant height, so we're going to find it. We have the radius, so we're going to use Pythagorean theorem to find the slant height. And the slant height happens to be the hypotenuse, opposite the right angle. So L squared equals 8 squared plus 15 squared. And so plug that into the calculator. 15 squared, so 289. And we take the square root of 289. We get 17. So now we have it. We can plug it into our formula. So pi times the radius is 15 squared plus pi times 15 times the slant height, which we just found, which is 17. Okay, and we multiply those. So the total area is going to be 15 squared. 15 squared is 225 times pi, plus 15 times 17 is 255 pi. Alright, again, since both of them have pi in them, we can add them together, and that will give us 480 pi, and it's feet, square feet. Alright, another good problem, again, making connections to Pythagorean theorem. So whenever you're missing one side, so find a way to have it, and if you have a perpendicular line, you can form a right triangle. And then a square, a sphere. So a sphere, just draw a circle, and then draw like about half circle, and then the other side we don't see, and the radius will be kind of in the middle there. We are given the diameter, so which should be 18, and so the radius will be 1/2 of the diameter, which is 9. Okay, so the total area, remember it doesn't have a lateral area, so total area is going to be 4 times pi radius square. So that's simple. So 4 times pi times the radius is 9. Excuse me. So again, make sure you follow the order of operation. So 9 square is 81, and 81 times 4 is, okay, 81 times 4 is 324 pi, and it's meter square. All right, so sometimes you may be given the total area and you're asked to find the radius. Just write the formula, substitute what you have, and solve for what you need. Okay, so circular figures, actually, I think they are easier than the prisms and pyramids, because for prisms and pyramids, they keep changing depending on the shape of their base, the polygon of the base. The area, the formula for the area of the base has to be different. But for the same thing for lateral faces, but for circular, because it's always a circle, the base is always a circle no matter what, so that makes things a little easier. All right, hope you get this. Good luck with your assignments. Shalom.